I'd like to review one more example from Chapter 2.5 that will involve vertical and horizontal shifts that will give a preview for some of the more complicated transformation problems that we will see later in the chapter when you have to deal with a sequence of multiple transformations. And so I just wanted to re-emphasize some key aspects of our methodology because they are important as the problems get more complicated. One thing I do want to emphasize is do not substitute values directly into the equation as you would with the point plotting method or when you develop the coordinate points for the initial base function. So I've highlighted that here in our lesson 2 file, right? Do not directly substitute values into the function, right? You want to identify the transformations, start with the base points, right? Start with your minimum of 5 coordinate points. We'll identify the transformations and the sequence in which they must be applied, and then we'll manipulate the table coordinates to get the final function's coordinate points so we can then graph it. But do not directly plug in to the function. So I want to step through example 3. And here we're going to see horizontal and vertical shifts in the same problem. The problem asks, use the graph of f of x equals x squared to obtain the graph of h of x equals x plus 1 squared minus 3. Now, as I emphasized when I went through the solutions of examples 1 and 2, the setup of transformation problems is very important. Again, remember that recipe analogy, right? What ingredients do we have? What's the order that we sort of need to cook them in or process them? That's the analogy you can think of. So here we have our function, right? Our base function is f of x equals x squared. That's the base function. Now, if you look here at this function, notice that there is this value of plus 1 inside the argument of the function, inside. So that is going to be a horizontal shift. And then notice we have a minus 3 outside the function. That is going to be a vertical shift. So remember, I've given everyone that guidance on how you can identify generically horizontal and vertical transformations. Vertical transformations will be outside the argument of the function. Horizontal transformations will be on the inside the argument of the function. Now, when we have sequences of transformations, it turns out that horizontal shifts will always be done first before any other transformation. And when we have different types, it turns out that vertical shifts will be done last. So in this case, our horizontal shift will be done first, then the vertical shift will be done second. So let's identify what the transformations are and what the manipulations are, and then solve the problem. So we have a horizontal shift, but remember that plus really means we're going to the left, a horizontal shift 1 unit. And so what's our algebraic manipulation? I want to subtract 1 from the x coordinates. So that's the first transformation you see, the x plus 1 in the square. Now then the second transformation is a vertical shift down 3 units. And so what's our manipulation there? There I'm going to subtract 3 from the y coordinates. So again, in these problems, this is really key. You really want to set up the problem with your transformations, right? What transformations do we have? What order do we do them in? What are we going to do algebraically with our table of coordinates to work through the problem? So our base function is the quadratic function. So let's come up with the base function points, right? So there's x and f of x. And here we can use our 5 standard x values, minus 2 to 2. And f of x is just x squared. So if I square these values, right, this would be 4, 1, 0, 1, and 4. And now what you're going to see when we get to sequences of transformations, I'll have some intermediate table of coordinates depending on how many intermediate steps we have. So I'll call this intermediate function generically just g of x. But what are we going to do? We're going to subtract 1 from the x coordinates. Now, since we're manipulating x, I don't have to change y. So I can just copy that column of y values down because we're not changing them. And now I want to subtract 1 from this column. So minus 2 minus 1, right? That's minus 3, minus 2, minus 1, 0, and 1. So there's the first manipulation. That's the horizontal shift. And now let's do the second transformation. And I'll call this x. And I believe their final function was h of x. So we'll use that letter. And now we're going to have a vertical shift down 3 units. We're going to manipulate the y coordinates. So again, I can just copy the x values, right? We're not going to change those. So let me copy that column down. Minus 3, minus 2, minus 1, 0, and 1. And now we need to subtract 3 from the y coordinate. So 4 minus 3 would be 1, right? 1 minus 3, minus 2, 0 minus 3, minus 3, 1 minus 3, minus 2, 4 minus 3, 1. All right, so notice we've gone through all the manipulations algebraically using the table of coordinates. And now let's go back to the text and look at the graph. As I've emphasized in the previous two examples, the text is going to show you these manipulations or transformations graphically each step, but they do the horizontal shift first. So notice there's our base function f of x equals x squared. It gets shifted to the left by 1 unit and then move down 3, right? Then there's that vertical shift. However, if you look at our table of coordinates, here's the first step, the horizontal shift. You'll see that some of the points we have in our table, there's match with the graph that you see in the text, right? There's minus 3, 4, there's 1, 4, and there's minus 1, 0, right? We have all those coordinate points in our file. And here's our final table of coordinates. And again, you'll see the points match, right? There's minus 3, 1 that you see here, minus 1, minus 3, which you see here, and here's that point, 1, 1. So again, we can calculate all the points of the final function, going through the transformations using the table of coordinates, making these algebraic manipulations, and then we can just plot the final graph. So as I asked after the last video, I would just ask everyone to then please just work on checkpoint 3. So work on checkpoint 1, checkpoint 2, and checkpoint 3. Try to execute it using this tabular method. That would be very good practice for how we're going to work these problems.